This is a real problem. I saw a talk by one of our PhD students about car following, and it has to do with this distance d and how it changes with time. This is pretty simplified, but it'll give us a good idea of what's going on. So cars A and B are going at the same speed, and the car behind, car A, decelerates higher than the car in front, so they would never hit each other. However, when car B slams on his brakes or her brakes, car A has a 0.75 second reaction time. That is, the car A starts to catch up for 3/4 of a second, and then car A puts on the brakes and starts to back off. And so the problem wants to know how far apart do these cars have to be before everything starts so that car A does not rear-end car B. So this is a pretty complicated problem, and so what I think we ought to do first is find out what the situation is after this 0.75 seconds. So let's start with that. So car B has at time 0, when the brakes first go on, car B has an initial velocity of 60 feet per second and immediately has an acceleration of minus 12 feet per second squared. And so what we want to do is figure out what the velocity is after 0.75 seconds and how far car B traveled after 0.75 seconds. Okay, so at t equals 0.75 seconds, since it's constant acceleration, v at 0.75 equals the initial velocity plus the acceleration, which in this case is negative, times t. So it's 60 minus 12 times 0.75 seconds. And that equals 51 feet per second. We also need to figure out how far car B has moved in 0.75 seconds. So again, since it's constant acceleration, we can use our constant acceleration equation, which in this class is s, not x, sorry. So s at 0.75 equals s0 plus v0t plus 1/2 at squared. So it starts at point 0. It has an initial velocity of 60 feet per second squared, 0.75 seconds. And acceleration is minus 12 feet per second squared and 0.75 seconds squared. And is 41.625 feet. Now let's figure out how far car A has gone forward in this 0.75 seconds. So car A has gone forward. Let's see, its initial velocity is also 60 feet per second, but the acceleration of car A for the first 0.75 seconds is 0 because the driver hasn't quite stepped on the brakes yet. So of course at 0.75 seconds, since there's no acceleration, the velocity is still 60 feet per second, and the distance it's gone forward, okay, so s minus s0, okay, so where it was and then how much forward it's gone, okay, is v0t plus 1/2 at squared, which is 60 feet times 0.75 seconds plus 0, because the acceleration is 0. And 3/4 of 60 is 45 feet. Okay, so let's summarize. Car A has gone forward 45 feet in that first 0.75 seconds. Car B, just a second. Car B has gone forward 41.625 feet. So car A is going to overtake car B and it'll crash. In fact, 45 minus 41.625 is 3.375 feet. So car A has gone 3.375 feet farther forward than car B. So one answer would seem would be 3.375 feet. However, car A is decelerating once the brakes go on, so I think it can actually be even closer than that before they crash. So let's work on this a little more. Okay, so here's the situation after 3/4 of a second. Car A has gained 3.375 feet on car B over that first 3/4 of a second. So this distance 0.75 is the original distance minus 3.375 feet. And so now the new initial conditions, car A is going at 60 feet per second. Car B is going at, what was the acceleration? The velocity, 51 feet per second. So A initially is faster than B, and so it'll rear end B. The only thing that is stopping this is that car A is really slamming on the brakes, and so car A's acceleration is higher. Car A is decelerating at 15 feet per second square, and B is decelerating at 12 feet per second squared. And so what we need to do is figure out what this D 0.75 has to be so that A doesn't hit B. And then once we get D 0.75, we have to add that extra 3.375 feet that car A caught up on car B over the first 3/4 of a second. Okay, so what we're going to do is figure out how much forward each car gets, think about it a little bit, and see how far that has to be so they don't hit. So to save some recording time, I just went ahead and wrote out these equations. And so what you have here is the position of car A at any given time t, and the position of car B at any time t. What I want to really highlight here is that the initial position of car B I'm taking as 0. So that means the rear bumper of car B is the origin. And so therefore the initial position of car A is minus D 0.75 behind the rear bumper of car A. So when these two cars hit, they will be at the same position. However, we have two unknowns, this distance, D 0.75, and the time when they hit. So we need one more equation. So in the worst case scenario, what's happening is car A is coming up on car B. Just before they hit, they're going at the same speed, and then car A starts to back away from car B, if you can picture that. Because remember, A was going at 60 feet per second, B was going at 51 feet per second, and so it's gaining on it. And so if they gain if A gains on B, and right when it's about to hit, they're at the same velocity, because A is decelerating more, A will start to back off. So we need the equation for the velocity of A, which is VA0 plus AT, and the velocity for B. And so we're just going to plug in the numbers for the initial velocities and the accelerations. So car A was going at 60 feet per second, but it's decelerating at 15 feet per second squared. And B was going at 51 feet per second, and it's decelerating at 12 feet per second squared. Okay, so what we can do now is solve this one for T, and then plug T into there, and set those two equal to each other, and then solve for D 0.75, and then don't forget to add the 3.375 feet. Okay, so here we go. Just before they hit, the velocities are the same, and that's probably the trickiest part of this problem. So 9 equals 3t, so 3 seconds. Okay, so at 3 seconds they'll be right on top of each other, okay, in the same velocity. And so now we can put the two displacements the same, so minus d 0.75 that will equal the displacement of B. Okay, and solving for d 0.75, we get 13.5 feet. So the initial distance that they're apart is that 13.5 plus 3.375, and that comes out to 16.875 feet. I'll go check if that's right. So I just checked the solution manual, which I know many of you have, and this is correct. I really don't like the way the solution manual solved it, so if you're looking at that, I think this physically explains it better. So I hope this helped.